Like being serious business. Alright, this is Red, and this is my quick tutorial on a steering front axle. Since apparently most people have not figured this out by watching my channel, or by looking at X-Ray's channel, we had something kind of similar which I've modified in order to make it work a little bit better. This is pretty much the best way of doing a steering front axle. People who put the master on top of a base prop, which is actually holding the wheels, it kind of works, but it's not really the same. I personally refer to this as a fabricated front axle, just because that's what comes to mind, but it means absolutely nothing. It's using rigid ropes. Alright, so we're going to start out, and we're going to place our wheels. Obviously, we have this large fuck-all flat plate in the center. I'm going to weight this plate 300, and the wheels 150. Pretty much any 0.5 to 1 ratio will do. I tend to go a little conservative on the weight of the steering master because it's also integrally part of the axle. Okay, so we got them placed. You're probably going, what the fuck are you talking about, Red? Alright, just shut up and watch. Fully precision alignment. First point, hit position. Second, mass center. Third one is going to be the bottom and center of this central plate. Fourth one, mass center of the other wheel. Fifth, hit position on the body. First and fifth will be in a line. You want to keep them so that it's all kind of like one axis, sort of, a hinge. You go mass center for numbers. Switch. And then go back to this. Now, if you want to have caster or in your wheel assembly, put that in now before you make the ropes. So I'm going to make a 10-degree caster. Anyways, we go to our constraints tab, rope, point 1, point 2, add length 0. For the purpose of illustration, I'm going to make the width 1. In actual practice, you can make it 0, or 1 if you really feel like it. It looks kind of strange. So we're just going to go right down the line. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. You can see we have a very bizarre looking arrangement. Don't worry, it'll make sense in a minute. So what you should have is this, where it's from body to front wheel to locate that wheel, underside of this floating steering master, not the, if you use setting, that's not the same, that I'll handle differently. And we have mass center of the other wheel, body. We have these ropes here, also locating by the mass center of our steering master. And back up here to the body. Now, mass center, and the top of our steering master. 1 to 2, 2 to 3, 3 to 1. So now what we have is this diamond-shaped arrangement, which is constraining our wheels and locating them relative to this steering master. You do not have to, but I also add that rope from wheel center to wheel center for extra rigidity. You don't have to do it. I personally like to do it. From this point, you've basically constrained it as you need to. I personally like to also do this sometimes, depending on the leg of the wheel, so I would add it in most instances, purely because you can. 1 to 3, 2 to 3. And these are from the wheel's mass center to a central point on here. Very complicated looking arrangement with the terms of the ropes, but you don't need to do that last bit. Nor do you need to do the one that's in the center of it. Oh, the fluffy seems to be on. One of the major advantages of this over the traditional, more often seen axle that has the steering master attached to a floating prop, which is holding the wheels, is that this is a hell of a lot more rigid. You have greater structural rigidity, and it's also a second advantage is that it's lighter. This thing here I'm putting in here purely because it's for modeling, or just as an example. Load it to 1. I would imagine on most live axles you would want to see the live axle. These are just ball sockets now. That just holds that in place. Alright, let's go back to the functional side of it. We're going to bring up standard road wheel arrangement, negative 180, 180, negative 0.1, 0.1, negative 0.1, 0.1, to lock the wheels on a rotating axis relative to the master. You feel the master, and you feel the other side. Now we're going to do something different, not used to. If you remember doing steering masters with a standard independent suspension, you usually simply restrict one axis, the turning axis. If you have caster, you turn 2 axes. You would want to leave one of them free, or probably I leave both of them free if it's axis. Instead on this, we're going to have negative 0.1, 0.1x, which means that it cannot tilt and change its camber. Not camber, I'm sorry, caster. Alright, the y is going to be negative 15, 15. That's just an example. This is actually the rotating, the articulation, which most of those crawler people will absolutely shit themselves over. Negative whatever it is for your steering in terms of degrees. I used 45 degrees steering. I'm going to ball sock this. Floating little piece of shit here. Feel this. And if you have that little extra thing floating around to make it look like you have a solid axle, you want to restrict it in the x-axis, because it's y and z. From here, we have pretty much assembled the entire thing. I will duplicate one. You can see it in action. So, obviously I've mentioned one of the benefits of having purty added. That is pretty plain. There's no wheel flags. I also would recommend that you had a free-floating ball socket just so that it doesn't fly the world, that central plate. Now, if you are using setting steering, whatever your setting plate is, you are going to restrict in the z-axis and setting plate this. For those of us, like myself, who are retro as fuck, and started learning this stuff way before, and aren't all that obsessed with our steering, what we would do is we would put a hydraulic mass center of this wheel here to the front of this. Mass center from this one, front of this, and that would be our steering. So it's actually very similar. It's kind of, in general concept and application, similar to an independent suspension with the floating steering master, that would normally be accessed on the bottom of a car, actually becoming, in addition, a load-bearing structure. As you can see, it does allow for articulation. We need to not make light on multi-fix. It does allow for articulation, just like any other vehicle. One of the reasons which I do like this is, as I mentioned before, the rigidity. But the main benefit in terms of what the rigidity does, it makes it so you have a light alternative to having an independent front suspension. With MAGE spherical wheels, independent front suspension creates a significant amount of difficulty with the handling because of that whole fucking swaying shit with the wheels, which requires a fuck ton of anti-roll if you have a high center of gravity. Instead, on this is going to be a lot less prone to that because the wheels are going to be, by the nature of their constraints, unable to do that swaying where it's basically rolling on the bottom of the spherical traps. So that's a big benefit. Second benefit, crawlers, the wheels don't smush as much, so you get a little bit better traction. You may get a little bit less, a little more, depends. Really depends on the utilization. If you do not have any free articulation laterally, the y-axis, on this master, you have something that has a fuck ton of anti-roll automatically built into it. Great for armored cars, great for anything that's going to have something large and rotating or moving on top of it, like a parrot. So there you go. So here's a quick example of a functional system which has been designed. You can see it has a leaf spring suspension with elastic. You can see the general diamond shape of the main steering master's constraints, as well as being constrained floating in one vertical axis, up and down only. It doesn't move side to side a whole lot on its own. Unless you drag that tire. There you go, you can pretty much see how it works. And obviously, as a suspension, it generally works pretty well. I personally prefer a live axle for anything which is heavy and load bearing. Much like real life, heavy trucks, shit like that, really benefits from the live axle a hell of a lot more than one would think. This here is probably going to be used to carry a lot of weight. It does not offer the same ride quality as independent suspension. It does not quite offer the same ride quality as those weird prop-based live axle fronts. I'll take the rigidity and the fact the vehicle doesn't feel like it's made of fucking glue and goo and shit. It doesn't feel like a dune buggy. It feels like it's actually constrained by itself. I can't stand the feel of advanced loop one. So there you go. That's my suspension tutorial on that. If you follow my channel, I'm probably going to be posting more tutorials in the near future. I'm right now very busy with classwork and women's, so alright. Till next time, that's Red.